I know. It's operator problem. So we founded the company last year, but actually we started working on the project the year before that. Actually, we built some of the first casino games over the prior year and then figured out how to get them on the blockchain. So we demonstrated our first game about a year ago at EdCon in Paris. That's running off-chain, and launched the company in April and did a token sale in June. So we're like one of the old companies in Ethereum. We're about 40 people, all based in Camden in London, and we are about to launch our live beta on mainnet, so it's a very exciting time for us. So our mission was to figure out how to create a gaming technology that's fully trustless. So we're assuming that the player and the casino are both untrusted parties, and so we wanted to build a technology that we could set loose into the world that would allow casinos, not us, but allow casinos to actually operate on the blockchain and provide a commercial quality of casino games that people would actually want to play, not cut down in any way, and yet use the blockchain to provide fairness and transparency for all of the gaming activities. Fairness is actually a very important point because the UK Gambling Commission recently published their poll that a very small percentage of people trust online casino games. Quite rightly, because you're expected to deposit your money into the casino and leave it in the custody of the casino while you play the games, and then you have to ask for it back when you actually want to cash out. And sometimes that could take days or weeks, or they might challenge it and so on. So there's a big fairness perception problem and trust problem in the public, and they'd like to be able to play fair games and know that they're getting a fair game. So we think that the technology that we built will help overcome that, because if we can guarantee a fair game, we think we might increase the trust level. We think we might actually, players might believe that they will get a fair game if we can prove the technology works. So with our technology, the player doesn't make a deposit into the casino. They actually play from their own wallet, and any winnings come back to their own wallet. So they don't have to leave any money in the custody of the casino, and they don't have to ask for it back afterwards because it is already in your wallet when you're done. So we've built this technology on top of Ethereum. Ethereum's been the first blockchain that has enabled smart contracts, which is what we rely on. We've built the entire casino, every casino game running in smart contracts. And if we were to just run them live on the blockchain, it would be too slow. You wouldn't get it would be fair because everything is transparent on the blockchain, but it wouldn't be fast enough to be fun because the block time is 15 seconds and you can't guarantee that your transaction is going to be in the next block, so it could be 30 seconds. And that would be an excruciating experience if you were trying to play a real-time interactive game and you were waiting each time you clicked the button for something to happen on the blockchain before you could progress to the next part of the game. So to solve that, we've created our own state channel technology that we call fate channels, and I'll explain why. Because originally we built that to enable real-time random numbers, because random numbers are an essential part of casino games, and having provably fair random numbers in real time is actually the initial problem that we were trying to solve. So we called them fate channels. As it happens, our fate channels have progressed in their capability and now do not only real-time random numbers and obviously real-time payments back and forth, but also we now execute the entire smart contract off-chain. So it's a full general purpose, Turing complete state channel solution where anything you could put in a smart contract, more or less, you could put off-chain using our fate channel technology. And what that enables are commercial quality games as good or better than anything people currently play. So if we can provide the experience to the customers, the players, that is as good as they get today, but we can increase the fairness and trust, we think we have a compelling opportunity. So just to explain the various pieces of the puzzle, these are casino operators. Yeah. And casino operators interact with players. They obtain their players through normal marketing means, banner ads and also affiliates. So affiliates are companies that exist in the gaming space, and they find players and they send them to casinos, and affiliates get revenue share from the players that they've sent to casinos. So that ecosystem all works together in conjunction with the FunFair technology platform, which uses fake channels to power the off-chain solution, has game transaction fees that are the method that you pay for their use, and also allows game developers to put their games on the platform. So it's a completely independent solution that allows any game developers to put games on the platform and any casino operators to run the platform. So yet again, we are not the casino. We are the technology provider to the casino industry. So I'm going to show you a video playthrough of examples of what we do. But actually, I can do a live demo because we have a working internet here. So, and I have my laptop. So if you want to see a live demo afterwards, we can. I need to enable sound, don't I? We should have sound playing. Does that work? No? Okay, so this is showing, we have a lobby system that we've built that picks up games from it picks up the games that the casino has decided to provide. The casino gets to choose which games they want to offer, and certain games have different characteristics that might be interesting to their audience. We've built the first 15 games, which are typical casino games like roulette and blackjack and so on. But obviously the game suppliers will pick up something else. Now this is showing what happens when you sit down at the table. You bring some money into the game using this. You're effectively opening a stage channel at this point. And the delay chain in real time, and they're all being cryptographically signed between both parties, so it's all rock solid. You can play multiple games, you can win, you can lose, all of that happens off chain, and then at the time when you click cash out down the bottom, it closes the channel and you get your money. So it all happens pretty quickly and immediately. Pardon me 1 second. So, okay, one more game, and then I'll show clicking cash out. And the opening and the closing of the channel is very quick, so it really only takes one transaction on the blockchain. So we typically keep the channel open only during the duration of the game, however long you want to play, like 50 minutes or hours, and then close the channel afterwards. So just to look on the blockchain, if we're able to see this. So here you can see the first number is what the player brought to the table. Oops, it's scrolled on already. So the two numbers, the first one was what the player brought into the table, and the second one was what the casino brought into the table. The casino brings a lot more money into the table than the player does, because the player needs to win something. So the casino typically brings like 100 times or even 1,000 times the amount that the players bring in, so that there's enough money to be won. Okay, we're back to... So the fake channel technology is a node-based architecture. Shall I mute it now? Probably a good idea. So it's a node-based architecture. Each casino will run a node. There could be hundreds or thousands of casinos. Hopefully, if we've done our job right and it's popular, one day thousands of casinos. We'll keep our fingers crossed. Each node is a completely separate instance of the technology, so it completely standalone. They don't need to talk to each other. Inside the node, it has the real-time random number generator, so I can talk more in detail on how the random numbers work if anyone is interested in that. And it's, as I mentioned, it's a general state channel, so it can run any code off-chain, not just payments. So it's far more useful than Lightning Network or Raiden, which only does payments. The reason we do it this way, there's only one copy of the game, and that is on the blockchain. So that allows for the auditing of the game. So regulators might want to audit the game code itself. Players or technical people might want to audit the game itself. So it is there, and when you actually start a game, you're starting an existing game that is running in a smart contract on the blockchain. So that way we get full transparency and provability of everything that happened inside the game and the outcome. Each node is capable of serving hundreds of players simultaneously, which is effectively thousands of transactions per second, and we can have as many nodes as we want. So the scalability is practically limitless with only a few hard limits. We've built this technology as an engineering solution, so we're not academics. This isn't a research project. This is a pure commercial product and everything we've designed is to work and to work today, not to wait for some future technology. We're not waiting for Casper or sharding or plasma or anything else. This is a deliverable solution today, and it does work. So this is showing two screens. The one on the right is actually the game running, and the one on the left is trying to show in diagrammatic form what's happening inside the state channel as it's being opened. So when the players selected a game, they will bring some money into the game, and the random number generator swaps entropy between the player and the casino. They both post their random entropy on the blockchain in that initial transaction. And from then on, it can free run, and it can run off chain. And that allows it to, it whizzed by so quickly, but in a second I think we'll slow it down. Imagine when the player places a bet or clicks spin, that sends a transaction to the casino sends a transaction back saying, yes, you placed the bet. Then they swap their random numbers and generate a unique random number for each game entry. And then it's decided who won, and the player says, I've won, pay me, and the casino says, okay, here you go. And all of that happens off-chain, and then when you click cash out or quit or do something that ends the channel, it's able to settle back onto the blockchain. So by exiting the game, you are effectively closing the channel and you get your money. The reason that this is very reliable and robust is because it's a full state channel solution, and it has dispute resolution built in, which is the key that makes it solid. So at every stage, when the random numbers are picked, when the bets are made, when the wins are decided, all of that is checked by both sides, the player and the casino. And if either side thinks they've been cheated, the cool thing is they can send the transaction off to the blockchain, and the blockchain will actually resolve it for them. So they can run off-chain for as long as they want, as long as they both agree. But if either party disagrees with what happened, the blockchain is the final arbiter, and the blockchain is the judge and jury. And I think actually, yeah, so I'm talking about it in more detail here. So the key thing is that it not only detects that a cheat has happened or a dispute has happened, but it can resolve it internally as part of the system, which guarantees a fair game for the player. We do our dispute resolution very quickly compared to some other state channel projects that are being worked on, in that we don't believe it's fair to make the player wait days or weeks for the outcome of a dispute. We would like to resolve the outcome in minutes, hours, or at most a day. We punish the cheating party so that they're disincentivized from cheating. So they, yes, Robert. The technology, I say we as in, we've built the technology so that if either party cheats, the cheater is penalized. Not only do they not manage to cheat because it can resolve it correctly, but also the attempt to cheat has a big punishment of you lose your money. And obviously the casino loses a hell of a lot more than the player does, but either side loses more than they were trying to cheat. So there's a big disincentive to cheat, and hopefully that means, like, A, the technology doesn't let you cheat, B, if you try and cheat, you're punished and reputationally damaged as well. So this should be a robust system.
And when's that money go to the other party?
Yeah, yeah. You've probably heard about payment channels, which, Lightning Network is an example of that, and Raiden is another example of that. And I just wanted to highlight some of the differences. So the most important one for us is that we're not just doing payments, we're running the entire smart contract. So any application that you can build on the blockchain, if you build it the right way, which is our way, then we can run it off chain. And the way, some people say you have to build it in a channelized way. We build it in a state machine way, in that it advances state with each move. So each transaction is a state change, effectively. We generate random numbers on both sides. The player and the casino both generate a sequence of random numbers, and each time a game needs a random number, both of them provide a random number, and then that's combined and hashed to get the actual random number that's used by the game. So it means that neither side knows what the random number is or could predict the random number in advance, but it's completely real time, which means that the games get to run fast. And random numbers are very important in casino games. In roulette, from where the ball lands on, what number it lands on. In slot machines, it would be like the position of the reels, and if you've got 5 reels, you'll need 5 random numbers, and so on. So we need a lot of real-time random numbers to make the games fun and fair. We're looking into doing a burn for transaction fees. Actually, we have a solution for that might not burn, so we may not do that. As mentioned, other payment channel and state channel solutions are talking about leaving their channels open for long periods of time and committing funds. The customer would have to leave funds in the channel for weeks, months, or years. We're not doing that. We're talking about very short-lived channels open purely while you're playing the game, and then when you quit the game, the channel's closed and you get your money. So you're not having to leave any money lying around, which we don't think is going to be very popular. In some other state channel solutions or payment channel solutions like Raiden and Lightning, they're relying on a multi-hop architecture. So they're relying on, to be able to send a payment from one random person to another random person, they have to route the payment through the network and find other people that have left money in their channels, so that they can effectively create a debit network and move the funds all the way through everyone that has a channel open. We think that is unreliable and only valuable when a lot of people are using it. When everyone has funds left in a channel, you can route easily from random person to random person. But when the network is young and there's not enough users of the network, it's very hard to generate a route. And so we don't think that multi-hop architecture is ready anytime soon. We think it is valuable when a lot of people are using it, and it's of zero value or low value when it's new and not very many people are using it. So we think that the single hop architecture that we're using, which is effectively player to casino, or in the more general case, it would be like customer to exchange, if they're using an exchange, that will be the more likely use of state channels, because you can get it to work today and you're not waiting for a network effect to make it work. You may not have heard of a company called CounterFactual, but there's a very cool Canadian company. I think the company's called L4, but they're working on a state channel system called CounterFactual, and we think that's the best other one that we know of, other than us. And the differences between what we're doing, Fate Channels, and what CounterFactual is doing, our smart contracts already exist. They live on the blockchain. They've already been published or deployed onto the blockchain, and so they're auditable by anyone, by customers, by auditors, by regulators, and so on. And so when we start games, we're playing games that are already in pre-audited smart contracts. And if someone tries to cheat and initiates a dispute, it gets resolved from a contract that is already on the chain. The reason why that's unique to us is that CounterFactual is doing the opposite. They are, in their case, the smart contract is not published on the chain. The two parties act as if there is a smart contract, and they communicate with each other with no smart contract. They just act as if it exists. And then if there's a dispute, one of the parties then publishes the contract onto the chain, and at that point then they can dispute it. But that incurs a cost in actually deploying the contract on the chain, which could be expensive, because we're doing real world applications here. These games are, thousands of lines of code, and to deploy these contracts on the chain is actually millions of gas. The slot machine is multiple millions of gas, and it has to deploy 5 contracts. Each one is millions of gas. So we think that to do efficient dispute resolution, it's ideal, at least in our case, to have the contracts already existing and not to have to publish them to cause a dispute. One cool thing CounterFactual is doing that we're not yet is context switching. So in our case, when you play a game, we open a new channel, and you play that game with an open channel, and then you quit, and then the channel is closed when you quit. And then if you want to play a different game, we open a new channel, and then you play that game, and then you close it. CounterFactual is allowing applications to context switch while the channel is still open. And we're researching that because we're not sure of all of the security implications of that. Because both our players are untrusted, and our casino operators are untrusted, and lots of other people, the game developers, are untrusted. We think there's quite a big attack surface potential for game developers trying to steal money from each other from an open channel. So we're researching that. It probably is going to work, but we're not assuming that works right now. So that's something that CounterFactual is doing, and that's one of the cool things they're doing, and we're not doing that. So in terms of games development, we support any third party to make games. Anyone can make games for this platform. A game lives in 2 parts. It lives as a DApp, which is the front end. It's the graphics, the sound, the pretty stuff, the interactive stuff. And also it is the smart contract, which is the back end for the games. And all of the outcome decisions, did they win? How much do I need to pay them? All that stuff is happening in the smart contract. And the smart contract is actually executed both on the player's computer and on the casino's computer. So they're both effectively running it off-chain from the source smart contract. And that way they can tell if something goes wrong. They can tell if either side is trying to cheat and trying to do something that isn't a legitimate state transition, then they can initiate a dispute. So it's rock solid in terms of making sure no one can cheat. Because fairness of games is more than just the logic of the way the game works, we have to whitelist the games, or someone has to whitelist the games, because fairness of games when you're playing in a casino environment is not only how it plays, but also how it looks. So you have to depict the cards correctly, you have to depict the ball landing on the wheel correctly, you have to show the player what's really happening and make sure that there's no misunderstanding or ambiguity in the outcome. So, yeah.
What's the minimum specs that are required at their end to make sure it all looks quite nice? Because that was really smooth on your...
Any browser. It runs fine on an iPhone or an iPad. Pretty... It depends how clunky, but obviously it's 3D graphics, so it's...
That looked amazing.
Sorry?
That looked amazing.
Yeah, and that's running in WebGL in any browser. So I would say if your computer has a graphics chip in it, so it's in the last 6, 7 years, maybe 10 years, it's probably fine. If it's the clunkiest Windows computer ever that doesn't have any graphics co-processing, then who knows? But I think every phone these days has a graphics chip. Every laptop has a graphics chip. So thank you. Yeah, but the cool thing is it runs in any browser, ideally any browser that communicate with the internet and with Web3. So the whitelisting process is the games developer will build their game in isolation on their own. They'll use our sample source code to help get going. Then they'll submit it to us. We'll check it for fairness, how it looks and feels, check the smart contract, and then we'll bless it. And then once it's whitelisted, they can put it in the App Store, and any casino anywhere in the world will see that game as whitelisted, and then they can use it. And games, there could be different variations of games that have different payouts. So some games might be, low volatility games where you can't win very much, but you also can't lose very much. Some games could have massive jackpots, and they could be high volatility games. You could even do zero edge games. Like, it's whatever you want to produce and whatever you think the market will like. The rules that we use for fairness are the same rules that any regulator in the world would use. So it's pretty common what a fair game should be. So in terms of scaling and capacity, this technology is relatively unlimited in scalability. Because each node is completely standalone and each casino runs their own node and has their own set of players, they're not dependent in any way on other nodes. And each node has hundreds of players and thousands of simultaneous transactions per second. One day you could have a lot of nodes and you could have thousands, maybe millions of transactions per second. And this is happening on today's Ethereum, not on a future one. The hard limit that we have is actually the opening of the state channel. And that is the thing that has to happen real time on the blockchain. And right now, there's 8 million gas per block. There's one block every 14 seconds. That will speed up because various things are happening. In the short term, people are optimizing the code of Geth and Parity to run faster. And when it runs faster, the miners can raise the gas limit per block. So that 8 million limit that there is today will be 10 million in a few months and 12 million or whatever. And then, of course, there's the block time, which will get shorter when Ethereum switches to proof of stake, to Casper, and then it will be 3-second blocks instead of 15-second blocks. So we think that the limitations of the actual underlying blockchain will improve over time and will never actually be a problem for us. And because we keep the channels open for the duration of the game, and the only time you're actually waiting for the blockchain is the opening transaction when you sit down for a few seconds, we don't think this is a limitation. So we launched this technology to the gaming industry in February at a big casino show called ICE at the Excel Centre. We've submitted to the UK Gambling Commission for a license. They actually need to license developers, even though we're not going to be a casino operator. We are a developer, and they like to license developers too. So we're waiting to hear back from them. They've already started asking questions because they don't really understand blockchain. We're going to be publishing our APIs and sample game source code in a few weeks. And the system is fully functional today. You can go to funfair.io, our website. You can go to showcase.funfair.io and play everything today. And we are going to go live in Q2, which I know is only days away now. But we're going to go live beta in a few weeks. And then if the live beta goes well, we'll go live soon after. So we're still intending to not only do the live beta, but also the first casino going live in Q2. Any questions? Go ahead, you were first.
So there's two. One is how to generate random numbers because
Yeah.
So a user obviously is not as capable as a casino, which would be a company. How do you? So if a user quits again because he thinks that there was foul play, does the state channel just remain open until the user disputes that? How do you handle?
No, there's a timeout as well. So.
How do you make it friendly for the user to know?
So we've built both sides of the state channel. So we've built the client side and we've also built the server side. So both sides know how to dispute automatically. So the user doesn't need to do anything. If one party has tried to cheat, the other party will automatically generate a dispute. But there is a situation where if one party switches off their computer, the other party needs to detect that's happened and then send a dispute saying they switched off, they didn't log out, they didn't close the channel. So, and that is handled as well. And then also another thing that you'll hear a lot about state channels is monitoring. So we will be able to support a third party monitoring both sides to make sure, and also initiated a dispute separately. But yeah, ironically, a not simple case for us is if the player is playing a game and doesn't actually cash out and just closes their laptop and walks off, because the casino then has to start timing out and waiting. Are they going to come back? What happens to them? Did they go to the loo? Are they like? Yeah, it could be. Yeah, but at some point after some number of hours, the casino is going to have to send they didn't close down properly. I need to close this channel, so I need to send a dispute. And then the player still has some time to come back and say, no, I didn't go away. I am here. You're lying. So there's full dispute resolution in there that will handle that case. While we're talking, I can actually run a preview of some new games that we haven't actually published yet. These are, there's an Egyptian and a medieval slot machine that we have yet to name. I'll put the sound back on if I can. So we can keep talking while we're just having that hand. Go ahead. Yeah. Yeah. Well, there's a gas cost, so yeah, there will be a cost. So you probably wouldn't dispute if you were owed 2p and you disputed whether you got it or not. It would cost you more than that to run the dispute. But if you were owed £100 or something, you would dispute it. It would cost pennies to run the dispute. We actually have a very efficient way of doing the dispute, so we only need to run the code that is needed. We're not deploying contracts. There's not millions of gas to run a dispute, but it is going to be hundreds of thousands. So it's not zero cost. But if you're going to generate a dispute, you're going to do it because it was worth disputing. Well, both sides have already put quite a lot of stake into the channel to start the game. So the player has brought some money into the channel, more than one bet, and the casino has brought a lot more into the channel. So there's a lot at stake, and so it's worth disputing automatically. Especially because the cheating party is going to lose a big penalty, much bigger than the amount they tried to cheat. So in terms of crypto economics, it works correctly, but also in terms of cryptography and the underlying dispute mechanism, it works as well as it could. So it's pretty robust. It's much better than what exists today. I think it's going to be, I need to give you exact figures, and I can't give you that today, but I think it's in the couple hundred thousand gas type range. So it's a similar amount to if you bought a token in an ICO. It's going to be that kind of ballpark cost. And obviously, you don't have to do it immediately. You can do it in hours. So you could wait till gas prices are cheaper if they're fluctuating. If there's high load on the network and you could wait for a time when there's low load, and then it's worth it. Sorry? Yeah, so we're talking pennies, not dollars. So you wouldn't dispute if you only lost pennies, but the reality is that by having this technology in place, people aren't going to cheat because the penalty for cheating is too great. It's financially great and reputationally great, so you wouldn't cheat, but this technology backs it up in a solid way that they can't cheat. So, try it if you can. Good luck. But, we want to create an environment that's completely fair for all parties. It's not just fair for the player in the casino, it's also fair for the affiliate and the game developer. Everyone gets paid automatically out of the Fate Channel service with a revenue share. Go ahead, Jim. Right, so people are working on, I'm gonna attempt to do a live demo. So people are doing poker today, and poker's a completely special case. So there's, you need to do mental poker algorithms, and you need to do shuffling, and it's a very special case. So we're not doing poker yet. Although my previous company and all of the founders used to do poker for the last decade, so we know poker intimately, and actually we've had enough of poker. Go do something else. And for multiplayer games, actually, the technology that we built today is a two-person channel. It doesn't scale into multiple people, but we'll have to build a different technology to do multiplayer games. But we can do. I'll just find a blackjack game. So, actually, that blackjack game is not online. So I'll show you a roulette. What else I don't know how to play that. Let's go back to Caribbean style, play on the blockchain. Let's see if it works. So when you sit down at the game, you will bring some money onto the table. So here, this is where I'm choosing how much to bring, and so we'll bring 10,000, test fund, which is even more valuable than real fund because you can't actually buy it. And now, when I click confirm, now it's been sent to the blockchain and we're waiting for the channel to be open, which should, there you go, it's open. And now we're playing real time. We can play as many games as we want. I can make a bet, ante, and then deal. And this is all real time, so we're not waiting for the blockchain at all here. We can win or lose, I have no idea. Have we got a hand? No, not really. I'll fold. Play another game. So all of this is real time. You play at the same speed that you would any casino game online. We'll play that one. And we lost the game. But if you watch now, if I click cash out, it's done. We've exited the game. It's been settled up on the blockchain. It's very real time. It's very immediate. So you don't feel like you're waiting around for the blockchain. If I click on I'll have to start another game because I've got a button that will let me. Actually, I can use Nevermind. If you look at the transaction we just did. So here you go. You can see, if I zoom up, you can see that the player brought 10,000 test fund, and the casino brought a lot more, 10 million fund into the table. And then the games were played, and then if we actually look at the, damn it, Etherscan doesn't let you see the, Etherscan isn't very good at looking at testnet. Token transfer. Yeah, so there, okay, now we can see here, this is probably the closing transaction where the stake channel closed, and you can see that the player only got 9,800 back, so the player had lost 2 games of 100 bets, and the casino won something. And then also this final one here is a burn, where we're actually burning the transaction fee, the ticket to play effectively that the system charges. So you can see all of that happens on the blockchain. It's all transparent and it just works. Any more questions? Yeah, go ahead. Yeah. Probably not going to burn anymore. We're going to do something almost as good, but the problem with the burn is that regulators don't understand. Turn the music off. Okay, so the question was, we said in our white paper we're going to do a burn of transaction fees each time there's a transaction, which is what actually you can see there. This final number here is the amount that was burned. So in the tech today, that's what it does. It does burn the tokens as they're being effectively a ticket, like a train ticket or a cinema ticket. When you use it, it burns those funds. So we do have that in there, but regulators aren't sure they want us to do it because they say a burn is like a dividend, which we don't think it is. It's not. A dividend, in my opinion, is distributable profits from distributable reserves in a normal company, and that's not what we're doing. We are taking a fee and burning it. It's not revenue, it's not even profit. So we don't think it is the same as a dividend, but because there's a question mark over burning of tokens, we have an alternate plan that's going to be almost as good. That is not going to require burning. Because it reduces the supply over time. I mean, tokens. We are the central bank. We've issued some tokens, which are our money. They're our cryptocurrency, and we wanted it to be deflationary, correlated with its use. So as people use, the more people use it, the more it reduces ever so slightly with each use. So that was our dream. If they don't let us do our dream, we'll do something different, but it'll be as good. So we're not worried about that. Yeah, go ahead.
I understand that fairness is a key issue for many players.
Yeah.
So who's going to educate players about blockchain and why it's fair?
Okay.
And how far do you need to get educated about that?
So some players you don't need to educate them very far. Crypto savvy people understand what provably fair means, and they understand some of the phraseology that we're using. But there is an educational process. We do need to explain to people, if you play games powered with this technology, it is guaranteed a fair game, and you want that because you know you're not going to get cheated. So there's a bit of an educational process, but it's helped by the regulators who are all preaching. The regulators, the UK Gambling Commission, are sending out tweets all the time saying the UK gaming industry is not fair, it needs to do more. So we think with the push from the regulators and the pull from the customers, we think that casinos are incentivized to offer fair games. And so we think more and more casinos will want to do that just to look good for their customers. So they don't, you know, if they're playing, if they have games that people don't think are fair or don't trust, even if they're not cheating people, just if people think that they don't trust them, that's bad enough. So we think that if we can create an environment that has completely fair games that are, with a robust technology, we think that we will get casinos using it. Also, a side effect is it's cheaper, and casinos want to make profits. So they don't need servers with this. Normally they have hundreds or thousands of servers on a remote island location in Alderney or in like Gibraltar or Kanawaki or whatever. So right now, all casinos that you play use what's called an RGS, a remote gaming server, which is a massive infrastructure in an offshore expensive location to run their games. And we are running the games locally on the client. So there's no servers needed. We just have the cryptography. That is actually my cue. We use cryptography to make sure that it's fair, but we don't need any servers. So it's actually cheaper.
Casinos educating rather than FunFair.
Well, we need to educate the public that this is fair, and we need to educate the casinos that this is not only fair, which the public wants, but also it's cheaper for you to operate it than your existing solutions. So we think that everyone wins, and also the regulators win because they get transparency, and the affiliates win because they get paid on time for every customer that they've sent.
Will casino guys get the same tax?
Yeah. I mean, the business model is the same. The casino games are standard casino games as existing all over the world. So everyone gets paid the correct amount. Last question, and then I have to go.
Just building on that question.
Yeah. I think it's a process. I think that the crypto savvy players will be this year, and that over time, when the general public realizes that you can play these games which aren't guaranteed to be fair, or you can play those games which are guaranteed to be fair and are just as cool. I think over time, players would rather play the fair games, and casinos would rather the legitimate casinos, which are most of them, would rather offer the fair games. So I think over time we'll find so. And as I said, they're cheaper, so the casinos make more money with our games than they do with their current games. So why wouldn't they want it? Thank you so much, everyone.